the last video, we learned how to declare variables as well as discover the size of each data type and how much it occupies space in memory. In today's video, we will perform some arithmetic operations as well as discover some new concepts in C++ like const variables and local and global variables. Let us declare two integer variables, and let me teach you a new way of declaring two variables of same type. So let's say int num1, comma num2. So if you have two variables of same type, you can declare them in one line. So what we did here is we declared two variables of type integer, num1 and num2, and we didn't assign any value to these variables. Now you can only do this if both of those variables have the same type, okay? So now we can go here and we can say num1 equal to 12, and so assign values to those variables, and num2 equal to 13. Okay, good. Now, before we go any further, I want to ask you a question. Can I go ahead and say num1 equal to John? So, equal to John, a string? Well, we're getting an error. First of all, C++ is a statically typed language. This means that the developer must specify the type of data before creating a variable. Look what we did here. We said int before creating the variable. So what we're saying here is that num1 should only store an integer. And what we're doing here is we are assigning a string to a num1 variable which should only store an integer. So we could go ahead and say 14 like this, and this will work perfectly. It will override the latest value, which is 12, and now num1 will store 14. So now that we have discovered, let's move on to do some arithmetic operations. We can do in C++ addition between two numbers. So what we could say is cout. I could say num1 plus, now here right now I'm just displaying a message, so plus num2 equal to num1 plus num2. And of course what I'm doing right now is I'm adding two numbers, num1 plus num2. So num1 is 12, num2 is 13, we should get 25. Now, if you want to run your program, you can hit the run button on top of the screen, but I want to teach you a new way. Let's open the command prompt or the terminal by pressing Ctrl G. And as you can see, I have PowerShell opened right here. You could go ahead and press on this arrow to select the terminal you want, but I'll go with PowerShell. And what I will write is the following command. So I'll say g++-o file.exe file.cpp. What I'm doing right here is I'm converting or compiling my C++ file. Let's press enter, and as you can see, we should not get any error. But you noticed right here that we have a file.exe right here. That's because when you compile your C++ code, the compiler generates a exe file or an executable file of this code. And this executable file will be fed to the CPU in order to be executed. So what now I'm going to do is I'm going to execute this exe file. What I'm going to do is say dot and /file.exe, and there we go. We executed our C++ file, and as you can see, 12 plus 13 equal to 25. Now the addition works properly. Now let's continue. How about we do some subtraction to those numbers? So let me go ahead here and add endl, that means a new line, and let me copy this and paste it right here. Now, for subtraction, instead of plus operator, I'll use the minus operator. And let me go ahead here and change the plus to minus. Remember, these here are only messages. And when you mention the variable name, it will replace it in the console by the value that it stores in. Okay? So now we could do subtraction and addition. Can we do multiplication? Well, of course we can. Let's go ahead down here, paste this, and instead of plus, we will use the asterisk sign, as well as replace it right here. Now can we divide? Well, of course we can. We could use the front slash right here and fix it right here for the message, and we can divide two numbers. So let us go ahead and run this. So I will compile my C++ code and then execute the executable file, and look at what we got here. So this is the subtraction, multiplication, as well as division. Now you're noticing here that we are not getting, well, a decimal value. If you open your calculator right now and divide 12 by 13, you will get 0 point something. But why here we're not getting this 0 point something? That's because both of those variables are of type integer, and integer variables don't store decimal values. And when you divide two integer variables, C++ will not return for you the decimal part of this division. That means it will only return for you, in our case, 0, not 0 point something. What you can do here is change the type of these variables to double. So if I go ahead and say double right here, everything will work perfectly. You still can add, subtract, and divide two doubles. Well, that works. So if we go ahead and compile this and execute this, so nothing changed here, but with the division, we can see that now we have decimal points. Now, if you don't want to convert or to change, your variables to double, well, what you can do here is leave it as integer, and I'm going to teach you something new. It is called casting. Well, casting allows you to transform a type to another type. So if you have an integer, you can transform it into a double. So how could you do this? We could use casting. So I could go ahead and say right here, static cast, there it is, and inside those signs or operators, I could say double. That means I want to statically cast or cast the following variable num1 to a double. So I could do the same thing for num2. I could say static cast double, and I mentioned what variable I'm trying to cast, which is num2. So let's try this out and see what we will get. So there it is. What we did here is we cast an integer to a double. So like this, we kept our original values or variables, to integer, but we converted them only here in this expression to double. Okay? So why we convert this to double? To make sure that when we divide them, we will get like a decimal point. Now we have another operator in C++ or in programming in general. It's called the Modulus Operator. It is represented with a % sign. So the Modulus Operator is referenced with a % sign. So I could go ahead and fix it right here. But what the Modulus Operator actually does? Well, the Modulus Operator returns the remainder of a division. Okay, so when you divide a number by another number, this Modulus Operator will return the remainder of this division. So let us see what this cout will give us. So I'll go ahead, let me clear the interface, by the way. I'll say CLS, and then I'll compile my C++ file, then execute it. As you can see, the remainder of this division is 12. Okay, now this is pretty useful if you want to determine if a number is even or odd. How could you do this? Well, let me go ahead and say right here, cout, I will say even, and I will say 2 modulus, where is it? Okay, modulus 2, and this should return for me 0, because 2 is an even number, and to determine if a number is even, you should divide it by 2, and if the remainder is 0, then it is even. As you can see, we got 0. That means 2 is even. What if I had here, right here, 3? Well, 3 is not even, so let us see if we'll get 1. And we got 1, so it's not even. And this is a use case for the Modulus Operator. You will see it further in this course. Now that we know how to perform arithmetic operations, let me go ahead and delete all of this, and I want to show you something. What if you want to, add num1 and num2 together, but store the result inside num1? Well, it's pretty easy to do. We could say num1 equal to num1 plus num2. What this will do is it will add num1 and num2 together, so 12 plus 13 is 25, and it will assign 25 to num1. So if I go ahead and cout num1 before the operation, so I'll say num1 right here, and let me copy this, paste it right here to see the before and after. So I'll compile and execute. So before we had num1 equal to 12, and after the operation, we added num1 plus num2 and assigned to it the result, so we got 25. But there is a shorter way of doing this. So we could go ahead and say, instead of all of this, we could say num1 plus equal to num2. This is equal to of saying num1 equal to, num1 plus num2. So this is a shorter and better way, and you will definitely use this way most of the times. And of course, we could do the same thing for addition, subtraction, multiplication. So minus right here, multiplication right here, divide right here, as well as modulus. Now there's a concept called increment. So when you say increment or you are incrementing a variable, you mean you are adding 1 to a variable. Let's see how we could do this in C++. Well, you could go ahead and say num1 plus equal to 1, but there's a even shorter way. You could say num1 plus plus. Well, plus plus here means you are incrementing num1 by 1. and this only works if we want to increment a variable by 1. But this is called post increment. Okay? However, plus plus num1, this is called pre-increment. So this is post-increment right here, but this is pre-increment. But what is the difference? Well, the similarities first of all are that both of them adds plus 1 to num1. But what is the actual difference? And let me go down here and say something like cout, and let me say plus plus, or excuse me, num1 plus plus. And let me go ahead and add a new line right here and say something like cout num1. Like this. What do you expect here to get? Do you expect here to get 13 or 12? Well, I will say 12. And let's see why. So I'll compile this, execute this, execute this, and yes, indeed, we got 12. And what's the reason? So let me tell you something. When you use post increment, what it does here is that it will display num1 in the console, then it will add plus 1 to num1. That is why we got 12 and then 13. But if you used pre-increment, let's say it, plus plus num1, and what this will do is it will add 1 to num1 and then display num1. So there's no need to use this one. So let me go ahead, compile, and launch. As you can see, we got 13. That's because with pre-increment, it will first of all increment num1 by 1 and then display num1. Also, there's something called decrement. When you say decrement, you are subtracting the variable by 1. So you could say instead of num1 minus equal to 1, you could say num1 minus minus. So this here is also post increment. And if you say minus minus num1, this is pre-increment. And same rules apply to the decrement. Now I want to show you something called const variables. So let me delete those right here and I will declare a const variable. So let us declare a variable called pi, 3.14. So I'll say const double pi equal to 3.14. Now we know that pi shouldn't be changed. It should always stay 3.14. So what we did exactly is we specified that this variable should be a const variable. That means the variable should not change. So that means if I go ahead and say pi equal to 3.45, and as you can see we are getting an error, that's because we have a const variable and we are trying to modify it. Const variables cannot be modified. And as you can see, const is not a type, it is a property. And remember, const is only a property. We still need to mention the type of data this variable will store, which is a double. Now let me go ahead and declare strings. Now I'll declare a string, or let me go ahead and declare a full name variable right here with those three variables. So full name, and full name will store name plus last name. Do you think this will work? Well, this will work, and this is called string concatenation. When you use the plus operator between two strings or multiple strings, you are actually concatenating or fusing both of those strings together. So right here, full name should give us John Davis. So let me go ahead and cout full name, and look at what we will get in the console. So let me open it and execute it. So we got John Davis. We concatenated two strings. Now there is no space here because we didn't specify that it should give us space. What we should do right here is concatenate an empty string, which will give us space. And if you go ahead and compile and launch, as you can see, John Davis, there is a space between them. So this is called string concatenation. Now let us talk about global and local scope variables. Now look at this program. What do you think it will output us? 12 or 24? Well, if we launch this program, it should give us 12. And we got 12. The reason is that 12 first of all, this variable right here is in local scope. What this means is that any variable declared inside a scope or within a block, so this variable is declared inside the main function, so it is inside main only, and it can only be accessed inside main. It cannot be accessed outside this function. That's because it has local scope or block scope if you want. So whenever you declare a variable inside a block, it has local scope. But as you can see here, this variable is declared outside the main. So it has global scope because it's not declared inside a block. So remember, whenever you declare a variable inside a block, it is in local scope. whenever you declare a variable outside a block, it has global scope. Okay? Now, how could you access global variables? So I'll say right here something like cout global variable, and let me put a space, and I will use something called the scope resolution operator and then mention the name of the variable or the global variable. Now, what does this scope resolution operator means? So we saw the scope resolution operator when we want to use cout. So we used to say std cout, but because of using namespace std, this will not anymore oblige us to use std when we are using cout. But also the scope resolution operator could be used to access global variables. So right here we are accessing the global variable called var, and it stores the number 24. So if I go ahead and launch this code, we should get 12 first and global variable called 24. And this is it for this course section. Make sure to check out the previous lesson if you missed it, link will be in the description, or check out my C++ tutorial playlist. Now thank you for watching this video. Make sure to click on one of these end screens that will appear right now, and I hope to see you in the next video.